Hello everybody, this is the second tutorial of the electrodynamic course. Uh, in this tutorial I'm going to talk more about vectors and magnitude I will cover, and I mainly work on cross product A cross B, which is another type of vector product. We already are familiar with dot product. I covered that in previous lecture, so if you have missed that, please take a look. Okay, so magnitude of a vector is defined in this way. So you can always use this equation to get magnitude of A, and it's basically using this equation because from previous tutorial we know if I have two vectors A and B, which turns out to be itself now, or dot product, then I have magnitude of first times magnitude of second times cosine between them, which in this our case is 0 and this is 1, and then it's A square. Therefore magnitude of A is a root square of this guy. So you can use always this equation to get the magnitude of a vector. Now I'm going to solve an example here. Example. So assume A is let's say 10 I hat minus 3 j hat plus let's say 6 k hat, and I want to get A. So let's dot product A by itself, and I know I write 10 I hat minus 3 j hat plus 6 k hat dot 10 I hat minus 3 j hat plus 6 k hat, and if I dot product these two, so 10 times 10 it's 100, so it's equal 100. I hat dot I hat is 1, so I won't write I, and that 1. I hat dot j hat it's 0, so although I get minus 30 by multiplying this guy and this guy, but that would be multiplied by 0 I hat dot j hat, so this is 0. And I hat dot k hat also is 0, so I don't write it. So it's very simple. You just need to multiply the coefficients of I hat by I hat, j hat by j hat, and k hat by k hat. So minus 30 minus 30 it's 9, and this guy times this guy it's 36. So it's 145. So therefore A, the magnitude is root square of 145. So this was how I used this equation. So let's write okay, before I go to cross product, let me to make things easier, let's write one more equation for dot product. I know you already know this because you have listened to my previous tutorial and I have covered. Oh, oops, I'm sorry, I don't know why my computer has some internal problem now. Okay, no worries. Okay, one last equation for or identity for A dot A. So I usually write I'm sorry, A dot B, I usually write A or B or any vector in this format. A1 I hat plus A2 j hat plus A3 k hat, right? And I have B the same way, B1 I hat plus B2 j hat plus B3 k hat. So if I do A dot B, since I need to dot product I hat by I hat and then by j hat and by k hat, and I know that product of I hat by j hat is 0 and I hat by k hat is 0 and only this one is 1, so it's kind of like this: A1 B1 and then j hat only by j hat is non-zero and the rest are 0, and therefore A2 and B2 will be only multiplied from this side, and the same thing for this guy Z, A3 plus B3, and this is always true. So we can write our equation or our dot product in this way. And okay, after this I will move to cross product, but let me write this guy here. Therefore A dot B, I will write it as sigma over, let's say, I from 1 to 3 AI BI. So remember, this is the same like here, it's 1 first, A1 B1 plus then I becomes 2, A2 B2 and then B3 A3, and then this equation is what you need to remember. Oh, I don't think you need to, oh, I'm sorry, I needed to remember, I needed to erase this other one. I will write that equation again, and then we can move to okay, A dot B. So you can memorize this, would be handy sometimes. Okay, now let's talk about cross product. So cross product here is the definition of cross product. So first I should tell you, cross product turns a vector while dot product turns a scalar, it's a number. So for example, as you saw, when I do A dot B, then it always is a number, because this AI is not a number. It can be, for example, 2, and this B is like another number times 3, and then you add these numbers, so at the end you have a number. So this guy is always a number. But a cross product always turns a vector, and this I here is component of that vector, like this guy is component of A and this other guy is component of B. So this guy is component of A cross B. So let me make it more clear. So let's say A cross B equals A cross B 1 I hat. So remember, this is a vector, but this is a number because it has a 1, right? A cross B, which is this guy, first coefficient or first component, so it's only a number. Plus A cross B j hat plus A cross B k, so this is third element, k hat. So this 1 or 2 or 3 is this I. So I can be 1 or 2 or 3. So if I know A cross B1 and A cross B2 and A cross B3, then I have all these components. I can write I hat next to this guy, J hat next to this one, and K hat next to this one, and build A cross B. So therefore this is all I need to determine A cross B, right? These three are all I need, and I can use this equation. Okay, this is summation over J, which is components of A, and this is summation over K. Both of them run from 1 to 3, and K is component of B. Remember, the order is important. A comes first, J, B comes second. Now, so here the weird thing is this epsilon. This is not weird, but if you are not familiar with this, it's weird. But I am going to make this guy crystal clear for you, so don't worry. Okay, so but remember, first, this has 3 indices. I, which is this I, so this I has appeared here, J has appeared here, and K has appeared here. Okay, now let's talk about this epsilon ijk. Its scientific name is Levi-Civita symbol. So Levi-Civita is an Italian name. But by the way, okay, so these ijk can be any number between 1 to 3, right? So for example, I can have 1 to 3, or I can have epsilon 2 1 3, or I can have epsilon 3 3 3, or I can have epsilon 2 3 2, and I can have 3 times 3 times 3, 3 times 3 times 3 epsilons, because I runs from 1 to 3, 1 to 3, and K 1 to 3. So if I multiply all of them, 27 components. I have 27 components, but don't worry, most of them are 0. Now I tell you. So these 27 guys can take only 1, 0, or -1. So they can take only 3 components, or I'm sorry, 3 values. So let's say epsilon I, J, K with some fixed I, fixed J, fixed K can always take one of these 3 only. Okay, now I'm going to tell you when it takes 1, when it takes 0, or when it is equal to -1. Okay, so first of all, for 0, whenever 2 numbers of these 3 are equal, this would be 0. So for example, all of these guys, like 2 to 3, or 2 1 1, or 1 2 1, or 1 1 2, these are 2 1s, 1 1, or let's say 3 3 2. So in any of these places, if you saw 2 same numbers, 2 same numbers, 2 same numbers, 2 same numbers, then that would be 0. This epsilon is 0, so this takes 0. So only if you have 3 different numbers in these places, then one of these 2 is true, or the value is one of these 2. Okay, so the 0 you can easily understand. It is 0 only if 2 of the values, 2 of these indices are equal or the same. So so the case for 0 is closed now. Now let's say, now let's see when these guys are -1 or +1. So maybe this equation looks a little bit scary at first, but you will see it's a strength. It's a strength. Strength later. So you will see how this guy makes some proving the identities much easier. Even I will show you how to derive these things from this guy. Okay, so to determine 1 or -1, all you need is to draw something like 1, 2, and 3. So you need always write 1 here, 2 here, and 3 here, like in a triangle. Then let's see, I'm going to determine this guy, 1, 2, 3. What is this guy? So none of these guys are the same, so therefore it's not 0. So the first guy here is 1, so I start from 1 here. Then the next one is 2, so I go from 1 to 2. And then after 2 it's 3, so I go to that. And you see it's clockwise, right? It's clockwise. The direction is clockwise. So when you saw clockwise, then the value is 1. So this is clockwise, or this direction. If you saw another direction like this, then it is -1. Now let's solve many different problems, many different like epsilons. Let's see what their values are. So I'm going to determine, let's say 2, 1, 3. I'm going to determine 3, 2, 1. I'm going to determine, let's say 1, 3, 2. It's enough. You will understand after these 4. Okay. So for this guy, the first, so you always have to have 1, 2, 3 the same order. So you can't have 2, 1, 3. Don't write it like that. Always 1 here, 2 here, and 3 here. So now here the first number is 2, so I start from 2. And then the next one is 1, so I go from 2 to 1, and from 1 to 3. So direction is counterclockwise, right? Because it is going this way. So therefore this is -1. Now the next one. So remember, this guy is called Levi-Civita symbol, and it is very popular in physics community. So now this guy first is 3, so 3, then it goes to 2, and then 2 goes to 1, 2 goes to 1, again counterclockwise, -1. Now this guy 1 goes to, oh I'm sorry, 1 goes to 3, not 2. Okay, let's erase these guys. Okay, 1 goes to 3, so 1 goes to 3, 3 goes to 2. So again counterclockwise. So let's now write a clockwise one. Let's say 2, 3, 1. Okay, for 2, 3, 1, I start from 2, then goes to 3, then 3 goes to 1. So it is clockwise, so the value is 1. Right? So it's so simple. So it takes 3 values, and if 2 of the numbers are equal, it's 0. Otherwise, if direction is clockwise, it's 1. If it is counterclockwise, it's -1. So simple. Now I'm going to use this equation to obtain or derive these like handy equations. Then you will later see how I can use these equations in doing the cross products. I will solve some problems for you, make it clear, make the problem easier to understand. Before that I need to erase these, so bear with me please, and I try to be as quick as I can. Okay. Okay. So now you understood what epsilon is, right? So now I'm going to calculate A cross B using this equation. So A cross B first component. So I'm going to determine this guy. So I is 1, therefore epsilon 1. Okay, so although J and K run from 1, but since this is 1, if another of these two things are 1, then it is always 0. So I don't write zeros, right? For example, 1, 1, something else, it's something 1, 2, 3, that is 0. Or if 1 something 1, that is also 0. So I don't write ones here. Okay, I don't write the 0 components only. I will only write the non-zero ones. Okay, therefore I am left with, let's say, first 2. Then so J is now 2. Okay, then K only can take 3, otherwise epsilon is 0. If K is 1 or 2, then epsilon is 0, so K only can take 3. Then for this reason, so now see, J is 2, therefore A 2, so A2, and K here is 3, K is 3, so B3, B3 plus, so this first one is always 1. Now J also can take not only 2 but also 3, but this time K can take 2. So if it is confusing for you, you can write all of them. So you can write 1, 2, 3, then 1, 1, 1, 1, 1, 2, 1, 1, 3, but these are all 0, and put this in this equation and then write all of them. It becomes a little larger, but you will at the end make these 0, because as I explained, they all take 0, and then only 2 of them remain non-zero, and these are only the 2. Okay, let's erase this one and also these. Okay, now come back to here. Okay, now I is 1, right, and J equal to already is taken, so J equal 3. Then in this case, K runs from 1 to 3, but only 2 is non-zero. Epsilon is non-zero for only K equal 2 in this case. So now K is 2, J is 3, so A 3 and B 2. Okay, now this is so I write 1, 2, 3, the same as before. Then the direction is 1 to 2, 2 to 3, so it's clockwise. So this guy is 1. This guy is 1. And this guy 1 to 3, 3 to 2, 3 to 2. So it's counterclockwise. This is -1. So therefore, all I am left with equals A2 B3 minus A3 B2, right? So now I'm going to calculate the other two components, 2 and 3, and write them here. A2 B3 minus A3 B2. I just moved this here, and I'm going to erase the other one. Okay, now let's calculate the other one. A cross B2 equals, so epsilon I is now 2, epsilon 2. So J can't be 2 anymore. It can be 1 or 3. So let's take 1. Then K can't be 2 or 1, because if it is 2 or 1, epsilon is 0. So it can only take 3. Therefore, now J is 1, because this is 1. So A1, and K is 3, and B3. Plus epsilon 2 is fixed, because 2 is here, and I is 2. And 1 is taken already for J, so J takes now 3. J also can takes 2, but then we have 2 2's, and then epsilon becomes 0. So this here, there is only 1 left for K. So K equal 1 is only non-zero for epsilon. And here J is 3, so A3, and this guy is 1, K is 1, so B1. So again 1 to 3, from 2 to 1, 3, 1 to 3, so it is counterclockwise, and this is minus 1, so this is minus 1, and this one is 1. So from 2 to 3, 3 to 1, so it is clockwise, this guy is 1. And so it's A3 B1 minus A1 B3, right? A3 B1. So there is a beauty in here. Let's say, let me A3 B1 minus B3 A1. So there is a beauty here. So if you see 1 here, then only you see 2 and 3 here, 32. If you see 2, 31, 31. And if you see 3 here, then only, I'm sorry, A1. A1 B2 minus A2 B1. So you need to always use this. So for here I have used that. So now I have these 3, I have these 3, so I have A cross B. So now let's make an example. Let's say A equals I hat plus 2 J hat minus K hat, and B equals 2 K hat minus 3 J hat. As I explained already, the location of these guys, K hat, J hat, I hat, is not important. So okay, now so now A1 is 1, A2 is 2, and A3 is minus 1, B1 is 0, B2 is minus 3, and B3 is 2. Okay, so therefore A cross B, so I need first this one is A2 B3, so A2 is 2 times B3 is 2, and minus a3, which is -1, so it's -1 times b2 is -3 I hat, right? This is I hat. Plus you can use the same thing here, this equation for here and this equation for here, to get A cross B. So let's see what, so I see some dots for the rest. It's 4 minus 3, so it's I hat only, and some values J hat plus some value K hat, but we know this is now I hat. So see A cross B turn out a vector, because I hat, J hat and K hat are vectors, so this is an important concept. Okay, now I'm going to derive these equations from the first one, and then we can use those equations later. So maybe, and I'm going to recalculate A cross B using these, and you will see how things are easier if I use these instead of that. But this is more basic, more fundamental. Okay, let me just erase this guy and then start calculating the identities. Then I will use these relations in next tutorials to prove some of the vector identities that I find important, and then we will move to real electrodynamic later. Okay, now I'm going to use to calculate I hat cross I hat. So in that case, A is I hat and B is also I hat. So this, if A equals I hat, this means A1 is 1 because it's coefficient of I hat, and then the rest are 0. A2 equals A3 equals 0, and the same thing for B because B also is I hat. Therefore B1 is 1 and B2 equals B3 equals 0. Okay, so now from here I can tell you that for example, I hat cross I hat first component equals epsilon 1, then only 2 and 3 and plus 3 and 2 are non-zero for epsilon, but so here I need A2 B3 because J is 2, K is 3, and here A3 B2, but see A2 and A3 and B2 and B3 are all 0, so this equals 0, and you can calculate the rest. You will find that this guy is 0. And you will later see that any vector that is cross product by itself would be 0. So the result is 0 for any vector multiplied by itself. So this is one of the differences between cross and dot. So in cross, I hat cross I hat equals 0, but for dot I hat equals 1. So you need to remember these relations. Okay, now the same thing, if j hat cross j hat or k hat cross k hat then equals 0, and you can use this equation to get these relations. I hat cross j hat equals k hat, I hat cross k hat minus j hat, and j hat cross k hat I hat. There is one relation that you need to remember, and that is if I cross a by b, it would be minus if I cross b by a. So I get a minus if I replace these things. But in dot product, that would be the same. And you can use these basic equations to prove this guy. B dot A. So remember these guys. So here, for example, I hat cross k hat equals j hat. That means k hat cross I hat equals j hat. So this is minus, this is positive now. Okay. So this is another relation you need to memorize. And let's also emphasize these two relations. So these are important. Memorize them. And then let's go back to another equation. Let me see what I haven't told you. So I told you this, I told you this guy, I told you about these. Okay, now I'm going to use these equations as the last thing in this tutorial to calculate A cross B, and A and B are here. So I'm going to again calculate A cross B. So let's now write A and B here. I hat plus 2j hat minus k hat cross, the place is not important, you can write j hat first and then k hat, it really doesn't matter. So now I'm going to cross product I hat by k hat, then I hat by 3 by j hat, and j hat by this, j hat that, and then this way. Okay, so I hat, so it's 2 from k hat, I hat cross k hat, then minus 3 I hat cross j hat, right? Then now plus 2 times 2 is 4, j hat cross k hat, j hat cross k hat, and minus 6 j hat cross j hat, j hat, minus 2 k hat cross k hat, and my plus 3 k hat cross j hat. Let me change the color, and now I hat cross k hat from here, I hat it's minus j hat, so minus j hat, and I hat cross j hat, it's k hat, so this guy is k hat, j hat cross k hat, j hat cross k hat, I hat, so I have I hat here. This j hat times j hat is 0, so this is 0, and this also is 0. K hat cross j hat, so here I have j hat cross k hat equals I hat. So if I replace k hat, I swap the places, k hat cross j hat equals minus I hat, so this is minus I hat. I used this equation, remember? So therefore A cross B equals minus 2j hat and minus 3k hat, 3k hat, plus 4 I hat, plus 4 I hat, and this was 0, this is 0, minus 3 I hat, minus 3 I hat. And you need to add these two, because they are both I hat. So 4 minus 3, 1. So it's I hat minus 2 j hat minus 3 k hat, and this is all. So this was easier, I guess, but this is more basic. So this is all for today. Thank you for watching, and please visit us at www.solvephysicsonline.com and ask your questions, whatever you have, even related to other topics in physics, and we would be happy to help you. See you later, and bye.